Okay, the next problem is a graph problem. So we'll break this into parts. So this figure shows a velocity time graph of a train, and it's going to ask us some questions, and we need to read this graph. So first thing we need to tell ourselves is that the story of this line is telling us about the velocity. So part A, which time was the velocity the greatest? If we're looking just for greatest velocity, we're just reading the y value. We can see this is the highest y value right here. So we'll go down to the time. We'll call that t equals 48 seconds. Okay, so if you're within a second, then your answer is good enough. Okay, at what time was the velocity the greatest? Oh, we just did that one. During what periods, if any, was the velocity constant? Okay, constant velocity, we would expect a flat line. So the only place that I can see on here a flat line would be this piece here. So that is when the velocity was constant. So we'll call that t equals 90 seconds. We'll call it 108 seconds. Again, if you're off by a second or two, I would probably forgive you. Okay, C, during what periods, if any, was the acceleration constant? Now, acceleration, now how do we find acceleration on a velocity time graph? Well, hopefully you remember on a VT graph, the slope of that line is the acceleration. So yeah, the rate at which this line changes, that tells us how it's accelerating. If we're looking for constant acceleration, then we need to be looking for constant slope. So constant acceleration, constant slope. So I see a couple sections here that look like constant slope. From here to here, that looks like a straight line to me. You might, I don't know, you might call this a straight line somewhere around here. It's really hard to say. I would forgive you if you didn't call that a straight line. If you thought that was a curve and you left that out, I would make it more obvious on your test. But another place we have a straight line is right here. So right here, this last section, the acceleration is actually 0, but that is constant acceleration. Acceleration of 0 is constant acceleration. So here we have a constant acceleration, here we have a constant acceleration, and here we have a constant acceleration. So we're going to estimate those times. We'll say t equals, I'll call this 64. Again, I would be really forgiving on these times. And the last one is when it is stopped from, we'll call that 108 again. So again, if you're close to these, then nice job. Okay, part D. When was the magnitude of the acceleration the greatest? So a magnitude we can think of as size, and we can kind of think of it as absolute value. So if we wanted to think of the magnitude, we can kind of think of it as if we took the absolute value. So we're not concerned about if the slope is positive or if the slope is negative. We just care how steep it is. So if we think about a guy walking up this hill, then we can kind of visualize where the steepest part of this line is. So the steepest part of the line, I believe, is going to be from this section right here. So again, it's hard to read this graph, so I'll call it from 64 seconds to 75 seconds. The book's answer is actually a little bit different. The book says from 65 to 83, but really it's hard to be exact from this graph. So if you got anything close to this, nice job. If I were to give you one on the test, it would be more obvious.